Tell me that again.
They're round.
Yeah, they're round. What does he mean they're round that makes critical points like this one funny? Uh-huh. Yeah, okay, so this thing rounds off, right, and the slope is 0. But what makes that funnier in Calc 3 than in Calc 1? Yeah, it's got to be flat in all the directions, right? You guys see that? So that's actually a big thing. That's going to take us about a day to actually sort out kind of how you would talk about the whole thing being flat there, right? You guys see that? So you guys have two really nice sets of level curves here. Does anybody see the X that was in our XY example? You see how you would make a level curve that's got an X in it? Somebody want to draw it, walk it? You can tape it, yeah. Ooh. You guys see that? Okay. Wrap that around.
That was way more easy than that was easier than walking.
No, that was really good. That'll look really slick on the video too.
They do a slow-mo.
Totally. So remember, it's got to be a level curve, right? So it's got to come up the hill a little bit. Somebody want to help us out? Okay, and then where's your level curve go?
Oh no.
Infinity.
Looks like it goes that way, right?
I thought it was just a branch.
You guys see how the level curve makes an X there? So what's happening there? Can you guys describe that behavior to me? Is that a max?
It's a min.
Is it a min?
Or inflection point.
Uh-uh.
It's infinity.
No. Come on, you guys know a word for this. So this point right here, right, at the X, it's not a local minimum. Why not? Okay, what's a local minimum? Yeah, it's the lowest point locally, right? Is this thing the lowest point locally?
No, it drops off.
Yeah, it kind of drops off on both sides, right? But is it the lowest point in some direction locally? Yeah, sure. But what's going on there? Can you guys describe that thing? You guys have a name for this already. Okay.
Intersection.
No. You guys are now throwing math words at me. Okay, is it a critical point? Yeah, the derivative seems to be 0 there, right? I mean, whatever the heck a derivative is going to mean in Calc 3, it's definitely 0 right there. No? What happens with... No? So what happens with x cubed? You guys remember what's weird about x cubed? It has an inflection point that's actually also a critical point. It's not a local min or a local max. It's a... It is a change in concavity on that one, but it's also... Starts with an S.
It makes an S.
It makes an S. It's a saddle point.
I don't think we've heard of that.
What?
Yeah, I've never heard that.
We didn't do real. We did it in
Okay.
this class.
So a saddle point is a critical point that's not a local max or a min. It's a transition in concavity, essentially. The reason we call it a saddle point is because of this behavior right here. You guys see it? This is a saddle in the mountains, right? When you're standing there, right, you've got two directions that you can go uphill and two directions you can go downhill. You guys see that? Cool. So that's happening where on our example over there? Yeah, that's at the origin on our a of x, or f of x and y is x times y. That's cool?